All right, let's take a look at this example where we want to come up with a polar equation for the conic section that is described. So right away, we see that we want to be parallel to the polar axis. That means that we are dealing with something that involves sine of theta, right? And we also see this part right here where we need to be 3 units below the pole, which indicates that the p-value is going to be 3. And because we're going to be below the pole, that means we're going to be using the negative form of this. So r is equal to EP over 1 minus e to the sine, or not e to the, but e times sine of theta. Oh, I keep saying to the. What's wrong with me? Anyway, so we have all the stuff that we need to write the equation. So this becomes 12, because that's e times p, over 1 minus 4 times sine theta. Now, since our e value is something that is greater than 1, we're dealing with a hyperbola. So if we were to try to graph this to get an idea about, a little bit more about what's going on, you would see something kind of like this. This directrix is going to be 3 units below. One of our foci is going to be at the origin. That's really one of the nice things about these polar forms of conics. And if you were to plug in some values here for theta, you would find out that if I were to plug in 0, sine of 0 is 0, so we would have 12 over 1, so that's just 12. Also, if I plug in pi, I still get 12. So it means you'd have key points out here on the edges with rectangular coordinates of 12, 0, and negative 12, 0. Now, before you start saying, I thought it's positive 12 comma pi, that means that in the pi direction, you're 12 units out to the left. Now, we'd also want to check out what happens with pi over 2 and 3 pi over 2. So at pi over 2, sine of pi over 2 is going to be 1, and so you would have 12 over 1 minus 4. So 12 over negative 3 is negative 4. And then if you plug in 3 pi over 2, you would have 12 over 1 plus 4, which makes this 12 over 5. All right, so if we put these points on here, 12 over 5 is the same as 2 1/5, so it would be somewhere right about here. So based on where the focus is, this one focus, and these points, and you have another one that's down here at negative 4. And say why negative 4? Because you're facing up, right? But your R value you get is negative 4, so you'll be going down. So because of this, and the way that we need to connect the points, you'd see something like this. And then we'd see something very similar down here. And because of where these points are, we know that the center is going to be somewhere right about here. Again, we can go through and do the math on that. So that would be what? What is that? 16 over negative 16 over 5. But let's check with the calculator and see if it somewhat agrees with us, right? Does it agree with my assessment of what I've done here? So 12 divided by 1 minus 4 sine theta. Now you see the graph doesn't show everything. This is from a previous window, so let's change this. So we go from, say, negative 6 to 6. And there are the two pieces just like I have right here. Okay, let's look at the next example. If E is 7, with a directrix perpendicular to the polar axis. All right, first of all, perpendicular to the polar axis means that we're dealing with cosine of theta. We have here that we have 5 units to the left of the pole, so P equals 5. So the form we need to work with is R equals EP over 1 minus e cosine theta. And the reason it's going to be minus is because we're talking about being to the left of the pole. All right, so e times p is 35 over 1 minus 7 cosine theta. And this is very much like the last problem that we had, where since e is a number greater than 1, it's definitely going to be an ellipse, not ellipse. It's going to be a hyperbola. Some of the key values, that's going to be kind of wild, I think. Yeah, so again, you could plug in values here. If I plug in 0 for theta, that's going to give me 1. So it gives me negative 35 over 6. If I plug in positive pi, I get 35 over 8, as long as I'm doing my math correctly on that. Now, if I plug in pi over 2, that turns this whole guy into 0, so you end up with 35 here. And if you were to plug in 3 pi over 2, you'll get 35. So you're going to have some really extreme values. So let's see what we can see here. So 35 divided by 1 minus 7 cosine theta. All right, so we only get this one little part right here, so we need to adjust the window. And let's go down to, let's look at negative 15. And we'll change the y to, let's make this negative 15 to 15. Yeah, there we go. So we kind of figured it would be a hyperbola that's going to be going on the outs because of cosine function. And yeah, the 35 is definitely going to be stretching it out there. All right, so we'll do a couple more examples here in just a moment.